everyone, my name is Peng Huilin and my partner is Xie Jiayi. The topics of our presentation is the starting point of Euclidean logic, the 5 axioms and the postulates. Euclid was born in ancient Greece around 300 BC. Speaking of Euclid, one cannot overlook his greatest work, The Element. This book has influenced many scientists and played an important role in shaping the modern mathematical system. Why is the Elements of Euclid considered so important? Because it established the foundation of the modern axiomatic system in mathematics. Before this, mathematical knowledge was scattered and unorganized. Through the Elements, Euclid brought all theorems together to construct a cohesive system. This system was built in the following way. It begins with definition, axioms, and postulates, which serve as raw material like water, soil, and stone. Logical reasoning acts as a mixture that combines these elements, producing theorems. These theorems, like bricks, come together to build the grand edifice of mathematics. Euclid established only a small number of postulates and axioms. The Elements contains just 5 postulates and 5 axioms. From these, he constructed an extensive array of theorems. The first postulate is that if you have 2 points, you can draw a straight line between them. The second one is if you have a straight line, you can extend it indefinitely. The third one is given a center and a radius, you can draw a circle. The next one is all right angles are equal. The last one is if a straight line falling on 2 straight lines makes the interior angles on the same side less than 2 right angles. The 2 straight lines, if produced indefinitely, meet on that side on which are the angles less than the 2 right angles. In addition, he also proposed 5 axioms to serve as the foundation for logical reasoning. The first axiom is things which are equal to the same thing are equal to one another. The second is if equals are added to equals, then wholes are equal. The next one is if equals are subtracted from equals, then the remainders are equal. The next one is things which coincide with one another are equal to one another. The last one is the whole is greater than the part. With these 5 axioms and 5 postulates, along with some definition, it is possible to derive theorem. A line segment can form an equivalent triangle. This is the first theorem in Element. It is proven as follows. Based on the third postulate, a circle can be joined with a given segment as its radius. Then, according to the first axiom, things equal to the same things are equal to each other. This allows us to prove that AC equal to AB equal to BC. Following this logical process, we can prove some theorems from the postulate and axiom, and then use these theorems to prove even more theorems, like a snowball rolling and growing larger. There are many interesting stories about the Elements of Euclid, among which the 5th postulate is also known as the mysterious 5th postulate. Unlike the first 4 postulates, which are half of a sentence, the 5th postulate is worded in a very long way. It's like an entire paragraph. This 5th mysterious postulate is known simply as the parallel postulate. This mathematician suspicious. It seems like Euclid made a mistake. Greek philosopher Proclus thinks it is a theorem. But if it is a theorem, we should be able to prove it from the first 4 postulates. Many mathematicians over the centuries tried to prove the parallel postulates from the other 4, but were not able to do so. In the process, they began looking at what would happen logically if the 5th postulate were actually not true. They tried to prove by contradiction. The idea is simple. You keep the first 4 postulates the same, but assume that the fifth postulate is false. Then you use those new postulates to prove theorem. And if that leads to a contradiction, for example, true equals to false, then it means your new fifth postulate must be wrong. Therefore, the only remaining option would be that Euclid's version of the fifth postulate is correct, but they cannot find the contradiction. Then around 1820, Jonas Berlier, a 17-year-old student, started spending his days and nights working on the mystery. After years of work, he realized that maybe the fifth postulate cannot be proven from the other four. It could be completely independent. He imagined that there would be more than one parallel line through that point, on a surface that is curved like this. You can draw more than one line that is parallel to the original line. We now know this as hyperbolic geometry. That's all. Thank you.